Okay, so the first term of an infinite geometric series is 21. The second term and the sum of the series are both positive integers. Then which of the following is not possible value of the second term? Okay, so I think we should go for the options in this case. Fine. So the first term of the infinite geometric series is 21. So in that case, the sum, I mean the infinite sum, that has to be 21 upon 1 minus r, which is just 82 upon 21, which is 21 squared upon 21 minus 82. So in that case, this 21 minus 82, this should divide 21 squared, right? So that's nice. Fine. What now? Let's just check some values. So suppose this is 12. In that case you will have that, and also by the way, a2 should be less than 20. Okay, that's like fairly obvious because this is positive integers. Okay, no big deal. So let's check for 12. So our a option, that gives me 21 squared upon 21 minus 12 is just 9. So is this correct? Yes, this is correct. This gives me 7 squared, which is 49. Our b option is that this might be 14. 21 squared upon 21 minus 14, that is 7. Yes, this is the integer, so like this is the integer. C is 18. C is 18. So 21 minus 18 is 3. Still it does work. Is not possible value of a second term. I mean, all of them did work, so why not? The first one is 21, the second term and the sum of the series are both positive integers. Right, so 82 upon 21, that has to be, right, so that has to be the ratio. So 1 minus 82 upon 21. Yeah, looks correct to me. Yeah, it has to be like that. So 21 upon 9, because 21 minus 12 is just 9 in that case. And okay, fine. Then you got 14 over there, which, okay, fine, so like 7, which is once again giving me something like, okay, I think all of these are permissible, so what's the problem? It should be none of these. In fact, all of these could be possible second terms, so not a problem at all. 18 upon 21 still less than 1, and the sum that's supposed to be 21 squared upon 21 minus 18, which is 21 squared upon 3, which is still an integer, so no big deal. For the 14 as well, the ratio is less than 1 and greater than 0, and you got 21 minus 14 is 7, so 21 squared upon 7, that's also an integer, no problem. For 12 we just saw it's 49, so no problem. What's up? Okay, so yeah, none of these, right? Just move on. So S is a proper subset of 0 to pi, and this denotes the set of values of x satisfying the equation 8 to the power of 1 plus mod of cosine x plus cosine squared x. Well, cosine squared x is mod of cosine x squared, doesn't make any difference, plus mod of cosine cubed x all the way till infinity, and it is equal to 4 cubed. Then s is equal to, okay, so this is like 8 to the power of 1 upon 1 minus mod of cosine x. Yeah, looks like that. Okay, cool. And this is supposed to be equal to 4 cubed, which is 8 to the power of, maybe I should write it as 2 to the power of 6 in that case. Maybe not. 8 squared will work, like 8 squared. Okay, so that gives me 1 upon 1 minus mod of cosine x, that has to be equal to 2. So that tells me that 1 minus mod of cosine x is equal to 2. So mod of cosine x, that has to be negative 1. Wait, that can't happen. Wait, sorry, that has to be equal to half in that case. Sorry, this has to be half. So that has to be half. Okay, cool. Which is basically the same equation as saying cosine squared x is equals to half squared, which is just like cosine squared of pi by 3. Fine, so that gives me x is equals to n pi plus or minus pi by 3, right? And s is from 0 to pi, so and it denotes the set of values of x satisfying the equation, right? So what values of x satisfying the equation which are in 0 to pi? I think that first of all pi plus pi by 3, well, that's out of the set. So pi minus pi by 3 and plus pi by 3, these are the only two values which will satisfy the equation, and also line 0 to pi. Okay, so yeah, looks correct. So pi by 3 and 2 pi by 3, that should be our set. Cool, let's move on. In fact, no, okay, fine, let's move on. The coefficient of x power 19 in the polynomial, I just thought that maybe I could just figure it out from this piece of information itself, but then you got this option there as well, so we have to go through the whole process. No problem, let's just move on. The coefficient of x power 19 in the polynomial x minus 1 into x minus 2 into x minus 2 squared. Okay, and x minus 2 power 19 is, so first of all, how many terms are there? I mean, how many brackets are there? There are 20 brackets, right? So from 2 power 0 to 2 power 19, there are 20 numbers, so 20 brackets. In that case, the degree of whatever this polynomial will turn out to be, that is 20. So the coefficient of x power 19 is the coefficient of uh, the term which has the degree which is one less than the degree of the whole polynomial, which is always given by the negative sum of the roots of this polynomial. But because they just factorized it for us, we already know that the roots are in fact nothing but 1, 2, 2 squared all the way till 2 power 19. So the negative sum of the roots, that's going to be negative of 1 plus 2 squared all the way till 2 power 19. No big deal, we can figure that out. So like 2 power 20 minus 1 upon 1, just like that. So yeah, that looks correct. It's just 1 minus 2 power 20. So that is the coefficient. And yes, it will be a monic polynomial. In other words, the coefficient of x will be, I mean, x power 20 will be 1. So no problem, that does work. Okay, let's move on to the next question. Okay, so consider an AP A1, A2, A3 such that A3 plus A5 plus A8 is equal to 11 and A4 plus A2 is equal to minus 2. Okay, then the value of A1 plus A6 plus A7 is, okay, cool. So you have A1, A2, A3, this is AP, such that A3 plus A5 plus A8 is equal to 11. Well, A3 plus A8, that is the same thing as, wait, no, that's not the same thing, unfortunately, no. So 8 to 5, 3 steps, 3 to 5, 2 steps, doesn't work. We could write it as 2 times of, no, it just doesn't work. Okay, so 3 to 8, there are an odd number of steps, that's why it's not working properly. Okay, cool. So what else do we know? That A3 plus A5 plus A8 is equals to 11 and A4 plus A2 is equal to minus 2. Then the value of, okay, just have to solve this linear equation, I mean system of linear equations. Okay, cool. So just do it now. We will have to find the values themselves, or maybe we could cheat a little. So A1 plus A6 plus A11, how can we do that? Can we somehow cheat it to make progress suddenly? Well, A4 plus A2, A8 plus A2, that's an even number of steps. And A4, A3, that doesn't work. Unfortunately, no. So subtraction something, I don't know. That's not working very nicely. And 1 2 3 1 to 7, there are like even number of steps. Okay, let's just solve this. So you got 3a plus 2 plus 4 plus 7, that has to be 13d, that has to be equal to 11, and a4 plus a2 is just 2a plus 3 plus 1 is just 4d. 8 plus 8 is like 16 minus 3. Okay, that's correct. That has to be equal to minus 2. Fine. So now just find the values of a and d. Okay, cool. So how can we do that? Maybe I'm multiplying this by 3 and 2. That will work. Or you could just simplify it. So like a plus 9 d, that has to be equal to 13. So now let's use this simplified equation. So you get 2a plus 18d is equals to 26. So 18 minus 4, that has to be 14d, is equals to 26 minus of minus 2 is just 28. So difference is equals to 2. Okay, let's plug it into some equations. Like a plus 18 equals to 13, so a equals to minus 5. So now we can find everything. We can find the values of a1, a6 and a7, no problem. So there's some that has to be 3a plus, okay, so a1 is the same thing as a6 plus a7, that has to be 5 plus 6, which is 11d, which is minus 15 plus 22. 22 minus 15, that has to be 7. Okay, so that's it. The value is in fact 7. Let's move on. So if ABC are in AP, then A upon BC and 1 upon C and 2 upon B will be in. Okay, ABC are in AP, and this looks weird. AP, GP, HP, something. I think multiplying it by something might work. So you got B, C over there. What about I multiply by BC? Let's try it out. So that will give me A, B, and 2C, I think. Okay, cool. So what will these be in? Don't know about it. Okay, that's not working very nicely. Like ABC are in AP, then what are these supposed to be in? So you got 2C over there. This is supposed to be B. This is like A. I don't know. Doesn't seem like these are in a harmonic progression, are they? If these were in harmonic progression, then in that case BC upon A, C and B upon 2, these would be in arithmetic progression, which pretty much means that BC, in fact 2BC, and then 2AC, and AB, but 2 times of that, like AB. Okay, fine. That these should in fact be in arithmetic progression, and we know that A, B, C are in AP, so we can write B as A plus C in that case. I mean 2B as A plus C in that case. So that will give me AC plus C squared, and then 2AC plus 2B over there. So like, I don't know, that's not working. These are not supposed to be in arithmetic progression. I don't think so. If these were in arithmetic progression, that would mean that 2C times A minus B, that is, okay, just write it like this. That would mean that 4AC is equals to AB plus 2 times of BC, which is nothing but B times A plus 2C. Okay, which means that 8AC would be equal to 2B times A plus 2C, which is equal to A plus C into A plus 2C. And certainly doesn't look like this is always true for any ABC in AP. So no, that's not the option which we are looking for. What about if these are in a GP? This is like a very random fact that these numbers would be in a GP. But still, I just try it out. So in that case, 1 upon C squared would be equal to A upon BC into 2 upon B. Okay, fine. Which is nothing but 2A upon B squared C. Now I can cancel 1C away. That will give me 1 by C is equal to 2A upon B. So 2c is equals to b upon a, but that's also like, wait, no, that's not working, nicely. That gives me b equals to 2 times of ac, which is okay, which tells me like 2b equals to 4ac. So that's also equal to a plus c because these are in a ap. So 4ac equals to a plus c, not always true. So these are also not in a gp. In that case, what about if these are in a ap? If these are in ap, then that would mean that a, b and 2c would be in ap, but we already know that a, b, c are in fact in the ap. So that will tell me that 0, 0 and c are in an ap, which means that c has to be 0. But that's not nice. Like, okay, this is once again just a special case. It's not always true. So yeah, none of these. Just one. So the sum to infinity of the series 1 plus 2r plus 3r squared plus 4r cubed keeps on going, is 9 by 4. Then the value of r is, okay, so s is equals to 1 plus 2r plus 3r squared, keeps on going. So you got r times s, that has to be equal to 1 into r plus 2 into r squared plus 3 into r cubed, keeps on going. So if I subtract that, that will give me 1 minus r into s. That has to be equal to 1 plus 1r plus r squared plus r cubed, keeps on going. So you got 1 upon 1 minus r. So that tells me s is equal to 1 upon 1 minus r complete squared. Okay, no problem. So we are given that this is actually equal to 9 by 4. That gives me 1 minus r squared is equals to 4 by 9, which is just 2 by 3 squared. Now you have two values for 1 minus r. So like you could have 1 minus r is equal to plus 2 by 3 or minus 2 by 3. So 1 minus r equals to plus or minus 2 by 3. That tells me r is equals to 1 plus minus 2 by 3. But unfortunately, if it was 1 plus 2 by 3, that just wouldn't work. So we are left with 1 minus 2 by 3, which is minus 1 by 3. Sorry, just 1 by 3. Positive 1 by 3 over there. So yeah, that's the value of r. By the way, it might be possible that in some scenario you have something which makes both choices possible, the plus and minus both of them, but it's not over here. Okay, cool. So you got 1 squared plus 2 squared plus 3 squared all the way till 2003 squared is equals to 2003 times 4007 times 334, and 1 times 2003 plus 2 times 2002 plus 3 times 2001 all the way, okay, cool, all the way till 2003 times 1 is equals to 2003 times 334 into x, then x equals, oh it's kind of a double summation question maybe. So 1 into 2003 plus 2 into 2002 plus 3 into 2001. So every time you go up on the left, you have to go down on the right, okay, and it will keep on going to, you have 2003 into 1. So what's the general format of every term? So you got tr is equals to r into 2004 minus r, which is 2004r minus r squared. Okay, so if we sum this up from r equals to 1 to 2003, that's exactly what we are doing over there. That's just 2004 into, first of all, you got r, which is 2003 into 2004 upon 2, okay, and minus r squared, that's supposed to be 2003 into 2004 into 4007, which, yes, it's over there, okay, no problem. Why did they give us this information? I don't know. Fine. So 2003, 2004, 4007. Yeah, fine. In fact, okay, so they just made our work easy. So that's like just 2003 4007, and in fact 2004 upon 6, that has to be 334 in that case. I, okay, fine, it's correct. So like, now what? uh, this is equal to 2003 times 334 times x. Then what is the value of x? So first of all, this cancels. Okay, cool. Then what can we do? 2004, fine. So like you got 334 over there. This is just 3 times of 334, so these will cancel as well, and you get a 3 over there. Okay, cool. So you got x is equal to 2004 upon 2, but into 3, so that has to be 1002 into 3, just 3006, minus this thing. Wait, that's not what we wanted. It's 2000. Wait, 407. Wait a second, that is not working. 2n plus 1, that has to be 4007, right? And there are in fact 2000. Okay, so why are we getting a negative answer? So you got 2004 into r, like that gives me this thing. So 3006, that 2003 gets cancelled, and 4007, and then 334, that also gets cancelled. Oh, come on, what is this value supposed to be? Minus r squared. Did we make some mistake once again? No, it doesn't look like that. We didn't make any kind of mistake. So r, which is 2003 into r plus 1, which is 2004, and that thing upon 6 is just 334. Oh wait, that thing into 6 is 334, so that's supposed to be 6 over there. Yeah, that's the mistake which you made. Okay, so that's more like it. So it has to be 1002 into 6, which is 612, I think. Yes, so 6012, fine, minus 4007, which is 2005, right? 2005 should be our answer. So that's it. I will see you in the next video.